Hi guys, you're welcome to my channel. Today we want to look at the introductory part of calculus, and it's very important you pay maximum attention to this area because it helps you to understand calculus very well. If you're a JAM student or YX student, then this class is for you. Now for us to get started, we need to know what we want to do. There are some basic areas that you need to understand very well before you can know or understand calculus as well. And those areas, they have to do with functions. When you talk about functions, we are talking about two major functions. We're talking about the transcendental functions and the polynomial function. The transcendental functions can also be called non-polynomial functions. They include exponential, logarithm, and as well as radicals, also trigonometry functions. Now when you talk about the polynomial functions, they are basic algebraic functions that has to do with the degree of positive powers. And that is what we are considering today. If you want to learn about trigonometry, you can check the description part of this video. I have a link to all video on trigonometry. And without any further ado, let's get started. When you talk about polynomial, when we say polynomials, what exactly are we talking about? Polynomials are those expressions with ascending or descending powers of variables. And when you talk about the power of these variables, they must not be negative. So ascending powers of variable or descending powers of variable that are not negative is what we refer to as polynomial. Let me give you an instance. If I have x plus 2 is a polynomial. Why? Because x has a power of 1 plus 2x that has a power of what? 0. So if you look at the power, it ranges from 1 to 0. That means it's descending. If I have 3x squared, for example, plus 4x minus 8. This implies that I have 3x squared plus 4x to the power of 1 minus 8x to the power of 0. So when you look at the power of the variable, you have 2, 1, and 0. And for those that doesn't understand what they call variable, variables are the unknown in a given expression or in an equation. And when you say constant, they are those known numbers like 3, 4, 8. These are constants. So in mathematics, we most times represent all these constants with A, B, C, D, and so on. And when you talk about the variables, we represent the variables with letters such as X, Y, Z. Am I making sense? So to mention but few. Now that you've understand polynomials, so if you look at all these examples we gave, they are examples that depict the descending of power. You can as well have example that talks about the ascending of power. For example, if I have 8x minus 7x, if I have 8, let me put it like this. If I have 8 plus 7x minus 2x squared plus 8x cubed. So when you look at this is the same thing as saying 8x to the power of 0 plus 7x to the power of 1 minus 2x squared plus 8x cubed. So when you look at the power, they are basically ascending. Can you see? So this is polynomial. This is also what? Polynomial. I hope you understand that now. Alright, so if you understand that, let's look at functions that are not polynomial. Because it's very easy for you to confuse some functions to be a polynomial of which they are not. For example, if I have x plus 2 plus 5 over x. So when you look at these functions, you probably think it's polynomial because you can rewrite this as x to the power of 1 plus 2x to the power of 0 plus 5x to the power of negative 1. So you can see we have a negative power. Because of this negative power, this function is not going to be a polynomial. Also, if I have a functions like log of x, 2x plus 3, if you look at this now, this is not a polynomial. Why? Because of the log. If I have e to the power of 2x plus 3, for example, this is not what? Polynomial because of the exponent. If I have a radical like this, the square root of x cubed plus 2x squared plus 5x. This is not a polynomial. Why? Because of this radical. The The radical can be square root, it can be cube root, it can be fourth root, and so on. So long it is a radical, then that expression or equation cannot be a polynomial. Also, if I have another form of index, if I don't have it like this, this is an exponent. If I have this exponent like this, let's say 2 to the power of x squared plus 4x, this is also not a polynomial. Why? Because of the base 2. If I rewrite this expression, I'll rewrite this expression as 2x squared multiplied by 2 to the power of 4x. So this is not a polynomial. It's not a polynomial not because of the multiplication, but because of the base. I hope we understand this. Now that we understand expressions that are not polynomial and the ones that are polynomial, then we can move on to the next area of polynomial, which is arithmetic of polynomial. So when you talk about the arithmetic of polynomials, we talk about carrying out algebraic process on polynomials. That is the additions, subtractions, and the multiplication. So if you want to carry out addition of polynomial, how do you carry out the addition or the subtraction of polynomials? So how do we go about it? Remember, when you talk about arithmetic, you talk about addition, subtraction, multiplication, division. So these are arithmetic. However, we can go further by looking at what? The factor theorem, the remainder theorem, factorization, and roots of equations. These are what we refer to as arithmetic of polynomials. So the whole of the things you are going to be doing on polynomial basically includes addition and subtraction, division, and multiplication. Division and multiplication. We are going to be looking at factors and remainder. Factors and remainder. We're also going to be talking about, this is going to be a theorem. And lastly, we talk about factorization and roots of equations. So these are everything about the arithmetic of polynomial. So let's start by understanding how to carry out addition and subtraction of polynomial. So when you talk about the addition and subtraction of polynomial, how do we go about it? This is quite simple. Just like you do your normal addition and subtraction in primary school. So the same way is what you want to do here. However, because of the degree of the variables, you might find it confusing, but there's nothing to be confused about. So let's start by looking at this example here. So if I was asked, or if I'm asked that I should add these two polynomials together, this is a polynomial and this is a polynomial. The question says you should add them together, right? How are you going to go about it? All you just need to do is to open this bracket first. That is, I'll have x plus 2 plus 3x minus 8. So when you add this, the next thing we want to do is to group them. So this is x and this one is also having x. So they have to come together. I will have x plus 3x together. And as well, the sign plus, which is what they asked you to do, that will be into brackets 2, and this one is minus 8. So if I have it like this, my result will be 4x, then 2 minus 8 will give me plus minus 6. Plus times minus will give me minus, and I have 4x minus 6. So this is the result of the addition of x plus 2 plus 3x minus 8. We can also consider the subtraction. If I have into brackets x cubed minus 4x squared plus 5x minus 1 minus into brackets x squared plus 4x plus 5. If I have this, how should I go about it? This is quite simple. Just like we did for the first one, we try to remove the bracket of this second one first so that we can see what we want to do clearly. So this is x cubed minus 4x squared plus 5x minus 1. And if you open this bracket, minus times plus here, that will give you minus x squared. The minus times plus here, that's minus 4x. And minus times plus 5, that will be minus 5. So the next thing to do now is to what? To collect the like terms together. So x cubed, there's no x cubed here. So x cubed can stand on its own. Then we have minus 4x and then minus 2x. You bring them together. Minus 4x minus x squared, rather, not 2x, minus x squared. Then here you have plus 5x minus 4x. And lastly, you have minus 1 minus 5. Now that you're done with this grouping, it's quite important for you to what? To be patient, especially when you are dealing with negative symbol. It's very, very important you be patient. So this is still what? X cubed. And this is minus 4x squared minus what? X squared. That will give us minus 5x squared. And this is plus 5x minus 4x. That will give us minus x. And this is minus 1 minus 5. That gives us minus 6. And this is the result of x cubed minus 4x squared plus 5x minus 1. And minus into brackets x squared plus 4x plus 5. Now that you understand how to go about what? Addition and subtraction of polynomial, then I think this should be plus because this is plus 5x minus 4x. Sorry, so this should be plus x. So as I said, you have to be careful. So take your time to check very well before you proceed to your next question. So let's see. Let's make addition and subtraction a bit more interesting by considering this question. If I have that P1 is equal to 2x plus 4, and you have that P2 is equal to 4x squared minus 3x. Now the question states that the first question here says find P1 plus 3P2. And the second question states that find 2P1 minus P2. So if you look at this now, this is how JAMB will probably ask a question under addition and subtraction. They won't ask you the question like they are asking the primary school students how to go about addition and subtraction. So they want to make it a bit what? A bit advanced. And they can come in this manner. So how should you answer this? Very simple. As a YX student, this is what I expect you to do. You pick the P1 first, and that's you iterate this question. P1 plus 3P2. That's equal to, so what's our P1? Our P1 is 2x plus 4. Then plus 3. What's our P2? Open a bracket. P2 is 4x squared minus 3x. So we therefore have this to be 2x plus 4 in brackets plus 3 times 4x squared. That will give us 12x squared. And 3 times minus 3x, that will give us 9x. So if we have this now, we can collect the like terms. However, if you look at this place, there is no x squared there. Therefore, I'll have 2x minus 9x plus plus 12x squared, then plus 4. So if this is what I have, 2x minus 9x, that will give us minus 7x plus 12x squared plus 4. So you can rewrite this to be 12x squared minus 7x plus 4. And that will be your result for P1 plus 3P2. So P1 plus 3P2 is equal to 12x squared minus 7x plus 4. So we can go to the second question now. where we are going to consider 2p1. So we have 2p1 minus p2. So how do you go about this? We say 2 into bracket p1 is 2x plus 4 minus into bracket p2, which is 4x squared minus 3x. So if this is what I have for my p2, then I can solve the question like this. 2 times 2, that will give us 4x. Then 2 times 4, that's plus 8. Minus times h, that's minus 4x squared. And this will be plus 3x. So we'll collect the like terms again. We have 4x plus 3x. Then we have plus 8 minus 4x squared. Therefore, this will give us 7x minus 4x squared, then plus 8. And this is going to be the result. But for us to arrange this, because your polynomial can either be ascending or descending. So if I leave my answer like this, then I'm not obeying what? The definition. So I'm going to rewrite this as 2p1 minus p2 equal negative 4x squared, negative 4x squared plus 7x plus 8. But this now, the power is now in a descending format. So you can either leave your answer to be ascending format or to be in a descending format. And if I'm to leave my answer in ascending order, this will be 8 plus 7x minus 4x squared. So you can either leave your answer like this or you leave it like this. Or, and JAMB want to test you, you can as well leave your answer like this. P2 minus P2 minus 2P1. So if you do that, then you're going to be having 4x squared minus 7x minus 8. So this can also be your result, but I don't think they want to do this because obviously you've changed the question by multiplying both sides by negative. But just to let you know, other forms in which the answer can come, we never can tell. The examiner might want to test you in this way. So I believe now that you understand the addition and the addition and the subtraction of polynomial. Now let us go to the multiplication of polynomial. So when you talk about the multiplication of polynomial, we do this by distributing one item over a polynomial at a time. So when you pick a particular item in one polynomial and you distribute it over the items in the other polynomials, what you are simply doing is you are carrying out the multiplication of a polynomial. Now let's see example of what I'm trying to say. Let's take, for instance, they are given a plus b multiplied by x plus y. A plus b, we assume that it is a polynomial, although it is a constant. Am I making sense? But you can make it a polynomial by saying this is ax to the power of 0 plus by to the power of 0. So you can have this. It's still the same thing as this, and that's the reason why I call it a polynomial. How are we making sense? So if that should be the case now, we can therefore go back to our question, that is to answer our question. We have a times x, so we just say distribute this particular polynomial, distribute a plus b over x plus y. So I have this, then plus b into bracket x plus y. So a times x will give you ax, and a times this will be plus ay. Then what you're going to do next is to distribute b over this same polynomial. Plus b times this, that will be plus bx, and this times this will give us plus by. So you can therefore rewrite this answer to look in this format. You can decide to bring the whole of the x together, that is ax plus bx, then plus ay plus by. Am I making sense? So you can have it like this if you want to factorize out y. And by the time you factorize out y and you factorize out x here, you guys see that this second polynomial was, it's like it was distributed over the first polynomial. But if you leave your answer like this, it's obvious that you distribute this first one over the second one. I hope you understand that. Good. Now let's look at another form of what? Example. Like if I have a plus b multiplied by a plus b. So this is a polynomial. This is also what? A polynomial. However, this is going to be what? Distributed over this. I'll be having a into bracket a plus b. Then I will have plus b into bracket a plus b. And there will be a times a, that's a square, a times b plus ab, plus b times a, that's plus ab as well. And this times this will give us plus b squared. I therefore have a square, this plus this, they are the same thing. That will be 2ab plus b squared. So if you have this now, you can see that this is going to be the result for this. I hope you understand this. Now let's take things slow. What if I have this particular one here? Let's say I have I want to make difference of 2 squared now. So because this one is often used, if I have something like a minus b into a plus b. Now I'm going to distribute this over this, and you can distribute this one over this also. So let's do that. Let's say this is a into a minus b plus b into a minus b. You still have the same result. Therefore, you have this to be a square minus ab plus ba minus b square. Therefore, you can have this to be this and this can cancel because they are the same thing. Then you have a square minus b square. So a minus b into a plus b. And this is difference of 2 square. I think you can see that. Now, I would like to go further from this because when you look at this, this is going to help you. It's one of the algebraic identity, and it's going to help you when you are dealing with limit of a functions in calculus. You can see a square minus b square is difference of 2 square. You can express them like this. This will really go a long way for you when you are dealing with limit of a function. So this is called difference of 2 square. So we can as well have another one like into bracket a plus b all square. So if you have a plus b all square, this is the same thing as saying a plus b into bracket a plus b. And by the time you expand this bracket, just like we have been doing since, you are going to have a square plus 2ab plus b square. So just distribute one over the other. So we can also have a cube, a minus b to the power of 3. That is a minus b cube. So if this is what you have, sorry, let me put this one to be square. If you have this, you are going to be having a minus b into a minus b. Of course, if you do the way we have been doing since, you have a square minus 2ab plus b square. So this is another identity. Also, you can have a plus b to the power of 3. And if you have this is the same thing as saying a plus b into bracket a plus b all square. So if you expand this bracket the way we have been doing since, remember we've expanded this before, so you can replace this with this. So you therefore have a square, or better still, let's do this together because this might want to take much of your time a bit so that you don't get confused. So a plus b, so I'll replace this a plus b all square with a square plus 2ab then plus b square. So if I have this now, I will have this to be distributed over this. So I have a into bracket a square plus 2ab plus b square. Then I have plus b into bracket a square plus 2ab plus b square. So if this is what I have, then I can expand this bracket. So permit me to clean this place off. Then I will have my bracket there. All right. So this is going to be a times a square. So that will be a cube plus 2a square b plus AB square. Then I can go for the second one as well, which is plus BA square, then plus 2AB square plus B cube. Therefore, I have this to be, if you look at this and this now, they are the same. This one and this one, they are the same. And this one and this one are the same. Therefore, I have A cube plus 3A square B plus 3B square, 3AB square, rather, then plus B cube. And this is another word, identity. So I'm going to leave you to try this. A plus B to the power of 4 and A minus B to the power of 4. And as well, you can try A minus B to the power of 3. And let's see what your result will be. You can let me know if you get it right in the comment section. So if you do it right, your result for this one is going to be A to the power of 4 plus 4A cube B square. So if I have this, so this is going to reduce 4a square plus 4a cube plus b cube, then plus 6a square b square plus 4ab cube plus b to the power of 4. Sorry, this is supposed to be, there's an error here, so this is supposed to just be b. All right, good. So, and the second one is going to be a square minus 4a cube b plus 6a square b square minus 4ab cube plus b to the power of 4. And that will be your results. And if you do this last one very well, your result should be a cube minus 3a square b plus 3ab square minus b cube. So guys, if you expand it very well, so this should be your what? Your result. So I'm going to be stopping here now for multiplication. Then we can go to what? Division. So let's clean this up. Now, for the division of polynomial, it's very important you as well understand this. And this is where the work lies, you know. In calculus, there are two major or three major things that's going to really give you problem. And you have to understand them very well if you really want to do well in calculus. And what are those three major things? Number one is rational functions. Rational functions is going to give you more complexity. It makes calculus interesting. And if you understand it very well, you're going to enjoy the process. And second thing is trigonometry functions. They are also going to what? Let calculus look interesting, but they can make it difficult for you if you don't understand. And the last one are the radicals. So if you understand these three very well, you tend to find calculus interesting. However, I'm here for you. So let's go on, guys. When you talk about the division of polynomial, it's more or less like your normal divisions. If I have something like 5 all over 2, my result is going to be what? 2 whole number 1 over 2. That is, you're having your what? Your quotient, your remainder, and your divisor. These three things are what you are also going to have when you are dividing your polynomials. So let's give an instance and let's see example on how to go about dividing polynomials. Let's say I gave you a polynomial x squared plus 2x minus 5, and I asked you to divide it by x minus 1. How are you going to go about this? So this is quite simple. We're going to go by using the long division to find what? The quotient and the remainder of this particular polynomial. So how do we go about it? So what we do is this. So we have this. This particular one is here, x squared plus 2x minus 5, and this is what? X minus 1. Now, you see this first number here, this particular number that you're seeing here, x squared, and you see this very first number that you're seeing here from the divisor, you have what? X. You have to think of a number or variable that when you use this to multiply this first one, it's going to give you this. That is, we need to think of a variable that when we use this to multiply x, our result is going to be what? X squared. So that means x. Because x multiplied by x will give us x squared, obviously, right? So if that should be the case now, the next thing to do is now to use this particular number that we have here to multiply all these numbers here. So x times x, that's x squared. X times minus x, that's minus x. So what do we do? What we do is to now subtract this from this. So how do we subtract? Just have your negative sign here. This is going to be what? Cancel. X squared will cancel, and this is going to become plus. That will be 3x minus 5. So we can still divide. Now you have to think of what number or variable can I use to multiply x to give me this first digit here, which is 3x. Obviously, you know that is going to be what? 3. So you come down to this place and say this is going to be plus 3. So if I say plus 3 times x, plus 3 times x is going to give me 3x. Then 3 times minus 1 will give me minus 3. So this and this will cancel, because if I put negative here, negative times positive will give us negative. 3x minus 3x, that cancelled. And minus times minus, that will be plus. That will be minus 5 plus 3. And that means my result is going to be what? Minus 2. So that means there's nothing we can do further, because there is no number that you can use to multiply and give you what? X. Sorry, there's no number that you can use to multiply this number to give you minus 2. Am I making sense? So we stop here and take this one as the remainder. Are we together now? So if this one is our remainder, we can now write our result as what? As saying that x minus 1 goes in x squared plus 2x minus 5. How many times? It goes there, x plus 3 times, and it remained what? Minus 2. I hope you understand this. So if you want to write this down, you can just write it down as x plus 3. Are we together now? X plus 3, then plus into bracket minus 2 divided by x minus 1. Or you can just write it as x plus 3 minus 2 all over x minus 1. So this is like O number. I hope you understand this now. So that's that about how to go with divisions of polynomial. So the remainder is minus 2, and it goes in it in x plus 3 times. So let's look at one more example so that we can be sure that we've understand this. All right, so okay, so another example I would like us to know is this. Let's say divide x cubed plus 3x squared minus 4x plus 2 by x minus 1. So this is what it asks us to what? To look into. How do we go about this? So simple. Of course, you just start by drawing this. Sorry. So you draw a long division line. Awesome. So we have x cubed plus 3x squared minus 4x plus 2. Then we have x minus 1 here. So what are you going to do first? You think of a number that can multiply this first one. That is a number that can multiply this one, this x here. That is going to give you what? X cubed. And that number is x squared. So if I use x squared to multiply x, my result is going to be x cubed. So I have x cubed, then x squared times this, that's minus x squared. Everything divided by, yes, so we want to subtract this now, right? So if you put a negative sign here, x cubed minus x cubed, they're going to cancel, right? So this is going to become what? Plus. That means you have 3x squared minus x squared. So, sorry, plus x squared rather, because minus here is going to affect everything here. Yeah, so there's a minus here. So that will make this one and this one cancel, and this one will become plus. Then you have 4x squared minus 4x plus 2. Good. Now you have to think of a number that will multiply this same x to give you 4x squared. And that's what? That number is going to be plus 4x. Plus 4x times this. Plus 4x times this. That will give us 4x squared. Then minus 4x. Can you see that? So we have our division sign here. Sorry, not division sign. So just take your take the difference. Sorry. This and this will cancel. So this is going to be what? Plus. So minus 4x plus 4x, that's gone, right? So we have plus 2 to be our remainder. So that means if you say x cubed plus 3x squared minus 4x plus 2 divided by x minus 1, your result is going to be what? X squared plus 4x remainder 2. Now the question now is it every time that we are going to be having remainder? And the answer to that is no. Not all the time you are going to be having remainder. So I would like you to look at this example for me and let me know in the comment section what you have as your remainder. So take this and let me know what you have as your remainder. So the question says divide x cubed minus 2x squared plus 5x plus 8 by x minus 2. So let me know what your answer will be. What was the remainder in the comment section? So the next thing we want to look at now is factor and remainders theorem. However, I'm going to like to stop here right now. So in our next class, we are going to be looking at factors and remainder theorem. So if you enjoyed this class, give a thumb to this video. And if you are yet to subscribe to this channel, don't forget to subscribe, because from now henceforth, we are going to take it from this scratch to the very peak of calculus. And then you can become expert in handling calculus questions. Until then, let's keep what? Solving mathematics.